All right, next question. Earthquake intensity I is given by the equation I equals I sub O times 10 to the power of m, where m is the magnitude measured to the nearest tenth on the Richter scale, and I sub O is the reference intensity. In 1906, the San Francisco Bay Area had an earthquake with a magnitude of 7.8 on the Richter scale. So what is the magnitude of an earthquake that is 158 times less intense than the 1906 San Francisco Bay earthquake? I would start by making my initial equation here. So of this original earthquake, so we have I, and we're equal to I sub O. We don't know what that is. We do know the magnitude, so it's 10 to the power of 7.8. Now we want to make these two equations relative to each other. So my second one is going to be whatever intensity this earthquake was divided by 158, because it's 158 times less. And the times there is key. That's why it's a division and not like a subtraction. And it's equal to I sub O and then 10 to the power of m. Now this equation can be rearranged a little bit to make it so that it's also equal to I. So then we're going to go multiply both sides by 158. So we get 158 times our initial times 10 to the power of m. Well, now because these are both equal to the same variable, then we can say, well, IO times 10 to the power of 7.8 is equal to our second equation, 158 times I sub O times 10 to the power of m. And we can divide both sides by I sub O. That's a constant. It's not something that changes, so you're allowed to do that. So you get 10.78 equals 158 times 10 to the power of m. Now our whole goal is to isolate m. So I'm going to divide by 158 on both sides. So I'm going to be left with 10 to the power of m is equal to 10 to the power of 7.8 over 158. And I'm looking for an exponent, so I'm going to turn this into a logarithm then. So m is going to be equal to log, well that's nice, log 10, and 10 to the power of 7.8 over 158. It can all be put in the calculator at once, and you get m is 5.6. Okay, on to the next question. So points P and then K, 2 and Q, 2, 1/3 lie on the partial graph of y equals log base b of x as shown below. So the value of K is. So the first thing we got to do is actually figure out, well, what is our base in this case? Now that's going to be able to come from this first point that we're given. We know both the x and the y there. So that means we can say, well, our y value is 1/3 when we have log base b, and our x value is 2. Well, I can turn that into exponential form. It's going to be b to the power of 1/3 equals 2. We're going to cube both sides, and we find that b is equal to 8. So now that we have the full equation, which is y equals log 8 of x, we can go and substitute our point that we know, or the part of the point, which is the y. So we know y is equal to 2. And we're looking for our k value, which is our x. So again, I can go and turn this into an exponential form. So I have 8 squared is equal to k. So that means 64 is equal to k. So our answer is D. So we have a numerical response next. So if log base 5x minus log base 5 and then x minus 2 is equal to 3, then the value of x to the nearest hundredth is. So we have a constant here. It would be nice if we could make both sides equal to the same thing, or same log. So we're going to go log 5, and I'll turn this into one log. It's going to be x over x minus 2, so that's our quotient law. Then here, well, we need to make sure it has a base of 5. So then it's going to, we want the answer to this to be 3, so that's going to be our exponent, and then the base of our power will be 5, so that these match. All right, so now that we have both sides with log 5, we can cancel out the logs then, and we're left with x over x minus 2 equals 5 cubed, which is 125. I can multiply both sides by x minus 2. So I get x equals 125 times x minus 2. Apply the distributive property, so I get 125x minus 250. And then I can subtract 1x from both sides, so I get 124x, and then add 250. And then I'm going to divide both sides by 124, and I find out that x is equal to 2.02. So we have a written response question here. So 2 rural Alberta towns are experiencing changes in population due to the new construction of a new highway. Equations modeling the population of each town, where P is population and T is the number of years after January 1st, are shown below. So describe the significance of each numerical value in each equation listed above. So we got to go back here and look. Okay, so here, this is our initial amount of people. Amount of people. Now that's true for both of these. Then we have to look inside. Well, this 0.97, that's a base. That's the decay or decrease in population each year. So that's going to be our decrease in population of 3%. And then here, this is showing an increase in population of 5%. Now, then it asks us, well, algebraically determine the number of years to the nearest tenth that it will take for the populations of the two towns to be the same. So we basically just have to make these two equations equal to each other then. So we're going to go 4,000 times 0.97 to the power of t equals 2,500 times 1.05 to the power of t. And now our goal is to determine what these t is actually equal to then. Now before I go and take the logarithm of each side to figure out what t is, I think we can probably get rid of either 4,000 or 2,500 just to make it a little bit simpler. So I'm going to divide both sides by 2,500, and I'll get 1.6 times 0.97 to the power of t is equal to 1.05 to the power of t. Next, I'm going to take the log of each side. So then I'll end up with log 1.6 times 0.97 to the power of t, which is going to be equal to log 1.05 to the power of t. Now I can use the product law to split apart this log. So I'm going to get log 1.6 plus. Now at the very same time, maybe to save a little bit of writing here, I'm going to use the power law. So this t is going to become my exponent, or sorry, my coefficient of my other log. So it'll be log 0.97. And on the other side, I'll use the power law as well. So it'll be t times log 1.05. Now I need to isolate t. So I'm going to put all of the terms with t onto one side. So I'll just leave log 1.6. And I will subtract our t log 0.97 from both sides. So minus t log 0.97. Then I'm going to factor out this t. So I'll end up with log 1.6 is equal to t, and then times our log 1.05 minus log 0.97. Just barely fitting it on there. Now we want to isolate t, so I'm going to divide both sides by this logs being subtracted. So I'm going to end up with t is equal to log 1.6 all over log 1.05 minus log 0.97. And when I put that into my calculator, I'm going to find out that t is equal to 5.9 years.